A question to begin. How do you eat an elephant? Answer one bite at a time. Welcome to BGP. We're moving from the little interior gateway routing protocols like OSPF and ISIS into the big mamma jamma, BGP, the protocol that helps us manage the routing table of the internet. This nugget. We're starting off with the core routing protocol concepts from our perspective, our routed world, meaning the service provider, which is fun for me because I have taught so much material from the enterprise, from the customer perspective, that this perspective from the carrier, same concepts, but totally different paradigm in thinking about BGP. So we'll look at where it fits, how we use it, the facts about it, and then a very special version of it, multi-protocol BGP. This artistic interpretation of service providers actually started as somewhat of a joke when I created it, but it turned quite handy as we've gone through this SPNGN2 series because it really gives us that good 10,000 foot view. So now I ask the question, from a 10,000 foot view, where does BGP fit in the service provider world? Well, you can see that I've replaced one of my aggregation nodes bracket, which is essentially devices, routers that aggregate multiple feeds into the service provider core, with this IP edge nodes. These are specific devices on the edge of the carrier network in the network design that link up to other carriers. This is how the service provider essentially becomes the service provider, becomes a transit system, allows traffic coming in from one carrier, let's just say this is Global Crossing, to into their system to feed their customers, maybe going out through another carrier. We'll just say this is level 3, Sprint, all of these different carriers that we peer with in the world today. Well, BGP is our language of love between us and all of the other carriers that allows us to exchange routes with them. So think of BGP as simply that, your language of communication. These guys are going to feed you their perspective of the internet. Every one of these carriers have their own perspective because they have their uplinks to other carriers. They have their different cross-link connections with each other. So they'll have their perspective of what's best out on the internet. So this guy says, well, I think it's best to go this way to reach Japan. And this guy will say, well, actually, I'm going this way to reach Japan. And they'll figure out their best routing table and then send all of those routes to you into your edge devices here, which communicate and say, okay, well, we believe the best way for us, let's just say this is you and I running our own CBT service provider, right? We believe the best way to get to Japan is actually to go out through ISP 777, which, whoever that is, and their connectivity and their perspective of how they see the best world. Now, in the BGP world, there are two major flavors. There is eBGP, which is the external version of BGP, which has its own set of rules that govern relationships. And there is iBGP, internal BGP, which allows us to feed this routing table internally to our other devices. So, for instance, we have in our core, giant devices. These are our CRS3s, essentially, that bring all of these different aggregation nodes together and bridge all this communication. These guys may be running BGP internally and peering with these edge devices, which are running BGP externally out here. So, big picture, how does this all work out? Well, CBT service provider, when they are formed, would go and get their own block of public IP addresses. Let's just say, for grins, that we happen to score a 150.1.0.0/16. Good old 65,000 block of public IP addresses. Well, we would then begin advertising that out to the other carriers that we have uplinks with, and they would put that in their routing tables, again, modifying their perspective of where they see 150.1.0.0 and their best routes to get there, and they spread that knowledge throughout the rest of their organization. Well, we then take that route and then break it up to all of our customers. So essentially, we would have our home customers that get distributed individual IP addresses through whatever kind of equipment we are using to manage that. So we subnet this thing up, we slice it up into all these different chunks and feed it to our customers. But at the end of the day, we then bridge this out to other carriers. Maybe we start to use different strategies, like, well, let's slice that thing in half and let's do 150.1.0.0/22 being one slice, changing that subnet mask, and we advertise that this way to start balancing the load of traffic coming in. There's all kinds of different approaches that we can take with BGP, and I'm already getting way ahead of myself, but I just want to see you kind of catch the wind of where this fits in the service provider world. Well, before I get too far ahead of myself, let me bring it back to the key facts of BGP, the place of BGP. BGP, which runs on top of TCP port 179, that's number one, a key fact, very much unlike OSPF and ISIS, which are their own layer 4 protocol. They have their own acknowledgement system. They don't use TCP or UDP. They're all kind of self-contained. This really makes BGP feel a lot more like an application than it does a routing protocol. And I'm going to reference that in just a little bit again when we see how it works. This maintains the external routes of the system. So again, let's say we are right here. We are ISP with the autonomous system 5934. First off, let's mention that as well. BGP has public autonomous system numbers and private autonomous system numbers, very similar to where we have public IP addresses and private IP addresses. These are registered. They are well known in the internet. They are recognized, etc., etc. So we have to register for one of these as we build our CBT ISP. To run BGP with all of these different carriers. So as we uplink, we've got our edge devices right here that I was just showing you on my artistic interpretation. These feed into our internal network. Now, what's in here? 10, 100, 1,000 different routers and switches and devices that we use to reach our customers. Our customers are coming off of here. So here's, customer 1, customer 2, all of these different customers that link into us that we provide them internet access. Well, we build the roads to get them there. We have all this equipment. We pull out our shovels and trench up the streets or peer with other ISPs that do and lease their lines and reach our customers, and we bring them into us. Now, we give them public IP addresses. So here's a public IP that we have assigned to our autonomous system number that we register, that we own. See where I'm going with this? But we also have an infrastructure. This is what we've been talking about in this series up till now. This infrastructure internally that uses OSPF or that uses ISIS to help connect this. So we have our internal routing, which helps our customer get out to the other areas of the internet, get out of our infrastructure. But we also have this external routing, which is all managed via BGP. So I come back to my statement right here. Running BGP on top of TCP port 179 makes it feel a lot like an application, and almost from and I'm going to use this word even though I don't like it, an ideological perspective. The idea of BGP, right, is very similar to being an application. We have our internal, and I'll say private infrastructure, you know what I mean, right? Private infrastructure, IP addressing scheme that makes all of our routing happen internally, and almost on top of that, it's almost like if I were to bake a layered cake, we have this private IP addressing down here that makes all of our internal routing happen, and on top of that, we run BGP. And all of these public IP addresses and public routes that just kind of float on top of this cloud. I can't put it any other way. It's a layered cake, right? So these manage the internal side of us, the private routing, the private IP addresses. BGP manages the external, which kind of floats on top of, but relies on us doing that internal infrastructure correctly. Does that make sense? I mean, I really wanted to divide those. That's why. It's so important that we have OSPF and ISIS tuned to ninja speed. So if there's a failure in our infrastructure, that CRS3 just went up in flames. Oh no. Well, our internal infrastructure can quickly route around that sub-second convergent to where our customers' public IP addresses don't even miss a beat. Because BGP by itself is extremely slow. It is not designed for the crazy fast convergence. It's designed to say, oh, okay, ISP in this autonomous system just went down. Boo! It's like a Mack truck hit a wall. Just think of a Mack truck hitting a wall in slow motion video on the History Channel, right? Because they do things like that. And so you have this Mack truck that's just going, and meanwhile, all of us in slow motion are going, no. Internally, we've got these little minions that are like, reroute, and they're rerouting all of our traffic out to this ISP, this carrier, as this Mack truck, crams into the wall. It hasn't even smashed the the front of the truck yet, and internally we've rerouted everything to happen, reacting on that. But the ripple effect of this Mack truck hitting the wall will be felt through the internet for hours. I mean, before the other side of the world feels that, could be hours. And then, somebody says, okay, we'll repair this ISP. Hey, we flew in new equipment, we replaced it, and it all comes back online. It's still going to be hours before the whole world reacts and adjusts their routing table to that ISP coming online. That's the design of BGP. Do you feel that? Because BGP deals with this Mack truck, this universe-sized routing table, and it can't be fast by design. So, I think I didn't look at all these bullets, but I think I've talked about BGP overlays. It rides on top. Now, BGP, this is a very unique thing of BGP. Neighbors do not need to be direct. OSPF, ISIS, a neighbor is a neighbor. They are connected to the same network. They're across the WAN link. They're plugged into the same switch. All that kind of stuff. Well, with BGP, we could have a neighbor on one side of the network. Well, actually, let's go with this guy. Let's just say this is us. And linking to a neighbor on the other side of the network, and there could be 50 different routers in between there. And these guys would never know. It's kind of like the private side, that layered cake with the two pieces. The private side is transparent to BGP to where it just kind of flies over it and sends it down here. What's the result of that? The result is all these devices in between maybe don't need to have the capacity to handle a routing table the size of BGP. These big mamma jamma routers on the edges will handle it, and they will communicate that to each other very much like an application does, right? They're sending that routing table. These guys just kind of make sure that the neighbor relationships between those BGP routers happen. They don't really care about the entire internet routing table. Now, that being said, that's usually in a carrier you're going to buy big enough equipment all the way through that you're going to be able to handle the BGP routing table. But my point in this not direct statement here is they don't have to be direct statements. Let me also bring in the customers here. Where are the customers? Why are they running BGP? Because I know that they can. Well, customers a lot of time will peer with us, and they may peer with a competitor, because they want redundancy. If our Mack truck of an ISP goes down, they want to be able to fail over themselves, and whatever routes and systems they have in their premises, they want to make sure is not dependent on just us as an ISP. Maybe they peer with somebody else, so they could do something like that. Or maybe they want to use BGP as a type of redundancy. Maybe they're not peered with a competitor at all. They have two links to two different devices, and they're kind of using BGP to advertise their own individual routes, which maybe are a little subnet of our routes. We've got that 150.100. Maybe we sliced off 150.1.52.0/24 and gave it to this customer because they paid us a lot of money for it, right? Well, they can then advertise that route, that little subnet of our route, to us. And I know it sounds weird, but we kind of built a little mini carrier out of them, and we can use BGP as kind of a keep alive to say, okay, well, if this customer router goes down or this router goes down, we can automatically fail over to here and use that to advertise. So that might be one reason, but customers and us have to be very careful that they do not become a transit autonomous system. Right? So if they bring up a link to our competitor over here and a link to us, and we form BGP without the right filters, this is a big thought process of BGP. Without the right filters in place, we could start advertising our networks through them, and they send it over here, and they don't have the right filters, so they essentially become a carrier themselves and a link between us and a competitor down here. Now you might be like, well, that's kind of cool. Your customer's paying you to become a link, right? Well, yeah, I guess, but maybe their connection speed is 10 megabits per second, and over here we have 10 gigabits per second. Well, now we've got this customer, which becomes a big bottleneck to our communication on them, and essentially they're being traversed. We're stepping on them to get to another carrier. Not what they want to do. So you have to be very careful. Know once more, and I think we've communicated this. This does require beefy devices to run. Both service providers and customers, if they want to run BGP, need to have beefy devices and beefy knowledge, because BGP has a lot to it. I did get ahead of myself. I had a whole slide on why BGP is run by the customer perspective. So let me just hit the high points here. Number one, single homed customers, meaning customers connected to one carrier. Let's say it's this guy, will use static routes. There's no reason for them to run BGP, just a default route to get everything, and that's how it worked. Multi-home customers, let's say this guy right here, will usually use static routes too. If they have, let's say, a connection with us at ISP1 and a customer a connection with them at ISP2, they'll usually do equal cost default routes and kind of load balance between the two. One request goes here, one here, and maybe even do policy routing to say these VLANs use this one, these VLANs use this one. I mean, all that's totally possible. It's only if you have a multi-home customer who have their own networks. Like I was giving you the example, 150.1.52.0 maybe is assigned to this guy, and he wants to advertise. That's the key. That network through multiple carriers. So that way, if this line gets cut or this ISP goes down, and well, let's not have us, right? Let's have them. Their line gets cut or they go down in flames. Then this customer out here or whatever's trying to reach them will be able to eventually, even if maybe this circuit gets killed, but this ISP is up, this customer will be able to go through and reach in that way to them. Essentially, it's just if you have a subnet to advertise out. Now, let me just mention real world. I've had customers very unpleasantly surprised at the lack of speed of BGP. They'll have their own little subnet, and that's one of the requirements, is they've got their own subnet, their own little autonomous system number here at the customer, and they're advertising this 150.1.52 out, and so they have maybe somebody connected to this ISP in the outside world, and they go, okay, let's pull the link. So they go, and they kill the link, and they find out this guy's, page unreachable. Maybe there's a web server here, right? Running an IP address from here. And this guy's trying to access it on his computer. It's like page unreachable. 5 minutes, 10 minutes goes by, and they're like, what's the deal? I thought we had redundancy. And you do. This ISP has connections, through other ISPs all the way back here, and we'll eventually get there. But it could take 15 minutes before this customer realizes, or this ISP realizes that this link is down and chooses to go an alternate route through another one. It takes time. Now, is it faster than calling up a fiber splicer to come out and dig up the ground and do a new fiber splice to make sure that line destroyed by the backhoe is repaired? Oh, yeah. You're talking days or weeks of downtime in that case versus minutes in terms of BGP, but is not the same speed as OSPF and ISIS. Now, I also want to talk about real world with this. Customers need their own IP block and AS number. Well, yeah, that's nice, but we're out of IP addresses, right? All the IP addresses have been distributed by the United States government. It is all in the hands of private entities at this point. So what's a customer to do? They want some IP blocks. They want it assigned to themselves. Well, you can negotiate, right? So if they link up, let's just say this is Sprint and this is AT&T. Sprint can say, hey, we'll give you our block. Let's just say 150.1.52.0. This is actually Sprint's block, but we'll slice it off and give it to you, and you strike up an agreement with AT&T that they will allow you to advertise that block to them, and you can use a private autonomous system number like 65,431, right? As a private autonomous system, there's a certain range of autonomous system numbers that you can use, so you don't have to register, and AT&T agrees to peer with that, and Sprint agrees to peer with that. Now you've got BGP without going to the United States government and trying to get your own real public autonomous system. Last thing is customers must be smart. They can easily become a transit autonomous system. They can easily blow up their network if they don't know what's going on with BGP. And for that, I've actually created an entire series at CVT Nuggets focused on nothing else besides BGP. That is something actually worth mentioning again to you, is that there is on CBT Nuggets an entire series that I created just on BGP. I created that series, and actually Cisco retired the certification, I think, like the next month. So it's a fairly recent series that was created, focusing on everything BGP, but at this point I would say it's not certification related. It's more of knowledge related that you'll be going after, but that goes through all the nooks and crannies of BGP in all its glory. So I encourage you, if you want more of that beyond what SPNGN2 gives you right now, definitely check that series out. Okay, facts about BGP. BGP does send periodic keep alives. Now, this is beyond the normal TCP keep alives that are run. So the BGP protocol itself kind of does think of it like a hello messages, but it's not. It's like an are you there message to the other side. It never does a periodic update. Imagine if BGP was like RIP that sends its entire routing table every 30 seconds. Instead, I mean, OSPF, ISIS, if a network goes down, OSPF and ISIS by design are like down, everybody knows about it in milliseconds of time, right? BGP is like, oh, network down. Well, let's add that to the next batch update that we're going to send over to router 2. Oh, that network went down too. Oh, then that one went down. Now, because keep in mind, how many times do you think a network goes down on the internet? How many times in that moment of silence that was just there did a network go down on the internet? Like 50, right? I mean, networks are going up and down, flapping networks all around the world, and that's why BGP has to contain itself. So the routers will sit there and they will batch their updates and send, hey, here's 50 updates of what's new in the world today, every 60 seconds or so you can adjust your routing table accordingly. Thus, the reason why BGP is so slow, right? BGP does have multi-protocol support. This is where we get into the multi-protocol BGP, where it can support other protocols beyond IPv4, MPLS VPNs, multicast protocols. I mean, very expandable. We'll talk about that. I've got an individual slide for that coming up next. BGP is used for, as we saw, customers connected to multiple ISPs. The core of enterprise customers, meaning I've actually consulted with a large credit card company where they actually have their internal core. Oh, it's almost like a carrier itself running OSPF and EIGRP. And actually, they run RIP because some of their mainframes need it. So they run this, and they use BGP as a stopgap. So they have their internal core, and then they run BGP as a divider between themselves and all their partners. I mean, you can imagine a credit card processing company. Think about it. What kind of relationships do they have? They tie in over the network. I mean, they need real-time inquiries. They need real-time updates, real-time information from banks, from merchants, from all kinds of different financial institutions. Well, how do you form relationships with these guys but minimize the risk of them messing up your network? Well, it would never be running one of these protocols with them. Those are trusted core protocols. BGP is an untrusted protocol. It allows you to exchange information, but has an element of untrust that allows you to filter, to nix, to prevent customers from advertising or receiving certain information. BGP is, think of like if we had static routes being totally administratively overhead centric, but totally in our control. Then we have BGP being a lot of control by the administrator, but some automated process, all the way down to something like OSPF, which is fully automated, very little administrative control, right? So I just thought of that. That's actually a brilliant way to describe where BGP fits. So core enterprise customers will use that as stopgaps between them and their partner institutions, or even divisions in their own company. Service provider transit interconnects, which that's everything that we were just talking about, meaning you're a carrier and you're peering to other carriers, right? That's what that means. Or exchange points. There's a lot of time where, for instance, you might be an ISP and you might have a presence, let's just say, in a data center. For instance, I deal a lot with IO data center. IO data here in Arizona. And so maybe one of your major facilities is an IO data. Well, a lot of times in these facilities, there will be all kinds of other carriers that come in to that facility. And one of them might say, hey, I'll throw 100 grand at some redundant devices, maybe some Cisco 6500 switches, and let's all just chip in, $100 a month. And we'll create an exchange point where we're, let's just say ISP1, can pay $100 a month and kind of chip into the cost to peer with ISP2, ISP3. I mean, they're competitors, but they're not, right? We're all just kind of in this internet love world together. So we want to have good connectivity. So maybe our connections through, all of our other carriers out here, we really have poor connectivity to ISP5 up here. We reach them, but it's through some back door. So maybe they just all get together at an exchange point where somebody has funded some good redundant gear, where all these ISPs come together, chip in $100 a month, and now we've got a new uplink to those carriers. Now, last thing I'll say on BGP facts. Golden rule. I have to emphasize. Last thing I'll say on BGP facts. Golden rule of BGP, you can't tell others how to route their traffic. Nor can they tell you how to route your traffic. And I know you're kind of like, what? Why is that so important? You'll see. As we get more into BGP, there will be often times where we are, we're an ISP, and we might say, you know what? I have a 100 gigabit per second connection up here to ISP 9, and ISP 10 actually links over here, but I only have a, let's just say, a 10 megabit per second, very pathetic, uplink to them. I would really prefer to have them go through ISP9 and have all of their customers go through ISP9 to reach me. Well, that's the golden rule of BGP. We can't tell ISP10 to go that way to get to us. They're going to use whatever their best strategy is. Now we can suggest to them, we can call them on the phone, we can beg them, plead them, send them gifts, everything else, but at the end of the day, the decision lies in their hands. Okay, last piece of BGP that I'm going to talk about in this nugget is the multi-protocol flavor of BGP, or what some people call MBGP. So BGP in RFC 2283 was upgraded with extensions. Until that upgrade, it was like every other routing protocol. It would exchange routes, form neighbor relationships, maintain its own routes, and populate its own routing table. Well, in RFC 2283, it was extended to be able to carry more, meaning routes that maybe don't belong to BGP itself. And I'm even hesitant to use that example. I think the best way is to give an example, right? We've been talking about BGP from a perspective of managing external routes with other ISPs. If we are the service provider over here and we've got these exit points to other ISPs that are out there, eBGP or BGP will manage all of the relationship here, receive the internet routing table and all that. Well, remember, in our service provider network in this series, we've talked about Metro Ethernet connections. We've talked a little bit about MPLS. And one of the flavors of MPLS that we saw was layer 3 MPLS, which is allowing the service provider router, this is us, to peer with the customer router, this is them, and form a relationship. It could be via OSPF, could be via EIGRP, via whatever, via static routes. And we can actually allow our router to peer with them and receive their private routes. So they've got 10.1.53.0 over here, and they have another connection over here somewhere further off in the United States, maybe a state away, maybe a city away, whatever, to another network of theirs that is 10.1.63.0/24, right? Now, the question I have is, okay, our router is forming a neighbor relationship, or even using static routes or something to form a layer 3 relationship with them. We're now seeing customer routes coming into our network. How do we separate those from our routes, whether they're external routes coming in via BGP or our internal routes running with OSPF or ISIS that runs our internal routing for the service router? Well, some of that is through something called virtual router forwarding instances. The other piece of that is multi-protocol BGP, allowing these routes to come in and be flagged as, think of it like a train car on the BGP train. MPLS VPN is what I'm talking about right now with this technology, and we can carry those routes through our entire enterprise. All of our routers can receive them, but they will be flagged as saying, well, this isn't your core routes. They shouldn't be added to the service router routing table. They're to be maintained separate in MPLS VPN instance whatever, and we identify that instance. Multi-protocol BGP can be the locomotive, if you will, that carries those routes through our network without actually allowing them to merge with the routing table of our network. Does that make sense? Kinda. I know you're like, maybe. That the train car analogy is really it. When you get under BGP, you can activate this by using the address family command. You can go under address family IPv4, address family IPv6, and BGP can carry whatever. This is wide open. So maybe other things come out in the future. I gave some examples. Current address families, like it can carry other IPv4 routes like this, could carry IPv6 routes, could carry CLNS routes. What on earth is that? That's OSI routes, right? If you've got ISIS running as a routing protocol, you could actually jam OSI routes in there. VPN v4, that's where a lot of this MPLS that I'm talking about, how a lot of times that's termed in that. But essentially, for now, just keep this concept in your mind. Multi-protocol BGP is what allows you to flag those routes as being carried by BGP, but being separate from your routing table. And with that, we take our first bite out of the elephant that we call BGP. We lay the foundation. BGP to the service router is one of those core elements that must exist because it's what allows the service router to interface with the rest of the ISPs of the world, exchanging routes to and from them. So we saw the facts about BGP, how it's kind of like an application running on top of the private network that we've built with OSPF or ISIS, and looking at the multi-protocol flavor of BGP that allows us to transport address families or other subnets that don't belong to us necessarily, and maybe belong to a customer or maybe just are some other element of our network separately so it doesn't impact our core routing table. I hope this has been informative for you, and I'd like to thank you for viewing.